Okay, so what I wanted to do is to go over some proofs that I gave out after school for those kids who showed up, and for those of you who didn't show up, you still have access to these. So I'm probably going to create 2 videos just for expediting getting them uploaded. So here we go. We've got a diagram. And again, we have to trust what we're told, not what it looks like. So our given is that we have segment ST is parallel to segment QR. We're also given that angle 1 is congruent to angle 3, and we want to prove that angle 2 is congruent to angle 3. Alright, so in the given, I already know something about angle 1 and angle 3, but somehow I need to involve angle 2 to get to my goal. So that makes me look at this idea of parallel lines. So I'm just going to kind of highlight my parallel lines for a minute and see if there's something that is revealed to me that I know about parallel lines that involves angle 2 somehow. And if you look at the parallel lines, and if they are cut by a transversal, angle 1 and angle 2 become corresponding angles, and therefore I know they are congruent. So I can get angle 1 congruent to angle 2. So that's my goal. So I just dropped myself a little note. I'm going to deal with corresponding angles, congruent, and that's going to be the method I'm going to use. Okay, so I'm going to go back and let's see if I can erase. Oh, no, that's not what I want to do. Okay, so I guess I can't do what I wanted to do, but that's okay. So now you've got my marked up diagram. So we've got statements and reasons. Now again, I still have a couple people who are forgetting to title properly. Also, we number a statement and its corresponding reason. So I'm going to put both the givens together. That segment ST is parallel to segment QR, and angle 1 is congruent to angle 3. Oops, sorry. That was my daughter coming in. So we're going to do reason 1 is our given. Now, I put all the givens together. Remember, you can split up givens if you want. So from the given, I was able to get that angle 1 would be congruent to angle 2. And the reason is if 2 parallel lines are cut by a transversal, then corresponding angles are congruent. So I don't need to be told they're corresponding angles. I just need to be able to see from the diagram that they are corresponding angles, and then I can draw the conclusion they'd be congruent because of this postulate 10 that allows me to conclude that. So now I've got angle 1 is congruent to angle 2, angle 1 is congruent to angle 3, so through angle 2 would have to be congruent to angle 3 through transitive property of congruence. Remember, with this, you do not have the ability to use substitution when there's congruence. The only property that allows you to substitute in a piece with congruence is the transitive property of congruence. And that's it. That's as long as that proof is. Okay, let's try another proof. This one. So we got line K, line L. We've got a transversal T. We've got a right angle symbol. We've got an angle 1 and an angle 2, and we have parallel arrow caps. So we are given that line K is parallel to line L. We're also given that line K is perpendicular to line T, and our job is to prove that angle 1 is congruent to angle 2. So let's look at what we've got. We've got K is perpendicular to T, which forms right angles. So if it forms right angles, then that tells me that angle 1 is a right angle. I also know that I have parallel lines, but angles 1 and 2 aren't traditional, any of the angles that we're aware of. None of our theorems or postulates deal with angles that are beyond the parallel lines, so on the outsides of them, on the exterior, so to speak. So, and there's no way to use the concept perhaps of vertical angles are congruent, because there's no way to name this angle that would be a vertical angle with angle 2, nor would we be able to do a vertical angle for angle 1, because again, there's no way to name that angle. So if there's no way to name an angle, we actually can't deal with that route. So I'm going to go ahead and erase those, since that's not going to work. So again, I can get a right angle out of angle 1. Okay. And now I got to think of what can I say about parallel lines in this situation. And then all of a sudden I started thinking, I know we have a theorem that talks about a line being, a transversal being perpendicular to one of two parallel lines. And it's Theorem 3.4 says, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other one also. So if I can get line L perpendicular to line T, then that can get angle 2 to be a right angle as well. And then if they're both right angles, I'll be able eventually to get them congruent to each other. So the next thing I'm going to use is that Theorem 3-4. So there's my plan. Those are the two major things that I'm going to do. Because from 3-4, I'm going to get angle 2 as a right angle, and then solve it out from there. Okay, so now I've got my plan and I'm ready to go. So I've got statements and reasons. First is line K is parallel to line T. Also, line K is perpendicular to line T. Okay, now, there are multiple ways to do this proof. I'm a little bit on the lazy side, so if I can do 2 steps in one, I'm going to do it. And what I mean by that is if I'm doing 2 different statements, but the reason is the same, I can put it together as a single statement with its matching reason. So I'm going to demonstrate that on this proof. I'll talk about alternatives to this. So the first thing I want to do is use that Theorem 3-4 to get line L parallel to line, oops, sorry, that's not what I wanted, sorry. I want to get it perpendicular. And that would be if a transversal is perpendicular to one of 2 parallel lines, then it is perpendicular to the other one also. Oops, sorry, I forgot the word other. So that's at Theorem 3-4. All right, now that I have both of the lines being perpendicular, and remember this is the other thing, your statement and reason numbers need to be directly across from each other so that your proof makes sense. So I can get that angle 1 is a right angle, and angle 2 is a right angle. And that would be definition of a perpendicular lines. I get a lot of people that want to say that I can say that measure of angle 1 is equal to 90, measure of angle 2 is equal to 90 because of definition of perpendicular lines. But you got to go back and read that definition. That definition says 2 lines that intersect to form right angles. We know that right angles measure 90 degrees. So that's, we can go from there. We cannot go from perpendicular lines to the measures equaling 90. We have to take steps in between, and that's exactly what we're going to do next. We can't use transitive in this place, or because they're both right angles, they're congruent. We have to prove it. So we're going to say the measure of angle 1 equals 90 degrees, colon measure of angle 2 equals 90 degrees. And so what we've got here is two angles are their measures equal 90 because we know the definition of a right angle. So we're always looking back at our statement, because often something in that statement becomes the reason that we can write the second statement. Okay. Now if I have two angles, oh goodness sakes, me and my counting today. Perhaps I should have my daughter helping me with this. Okay. If I have two objects whose measures are the same, then I can say they are equal to each other. So I can say measure of angle 1 equals measure of angle 2. And then that gives me, that's substitution, or I could say transitive, property of equality. So transitive and substitution are somewhat interchangeable. I don't think most people would bat an eye if you used them interchangeably. Traditionally, substitution is when you're replacing a piece of an equation. Transitive is when you're replacing an entire side with an entire side. And then I can get to angle 1 is congruent to angle 2 through definition of congruence. Okay, so again, you could have done angle 1 is a right angle as step 2 through the definition of perpendicular lines, then brought in that line L is perpendicular to line T through theorem 3-4 as step 3. Step 4 would have been angle 2 is a right angle through definition of perpendicular lines. And then you could have done step 5. You could put the two measures of the angles equal 90 degrees. Or you could have said that measure of angle 1 equals 90 right after you told me it was a right angle. So there's so many ways to make this a longer proof using these steps in a different order. But you cannot get angle 2 as a right angle until you tell me that line L is perpendicular to line T. All right, and before I quit on this one and end this video and start the new one, I do want to relay one thing that I've seen kids over and over have a confusion with, and that's that idea of congruence. So let's talk about the definition of congruence for just a minute. So if we have congruence versus if we have equality, okay? Actually, let's do this. We'll change these colors just so that the line doesn't trip your fan, get you all confused. Okay? All right. When it comes to congruence, we're talking about an object being congruent to an object. So an angle congruent to an angle. We're talking an object congruent to an object. And that means we would have segment AB congruent to segment AB. When we go to equality, now we're not talking about a thing, we're talking about what it measures. So to indicate we have a measure, we do M for the angles. Because I can't take the angle symbol off. If I just said MA, nobody would know I was talking about an angle. Okay? That would be equal to the measure of angle B. Now when it comes to segments, now what I do is I take off the segment symbol. And all I have is AB is equal to CD. Now, this is actually the length of segment AB is equal to the length of segment CD. And again, there's only one object in all of math that's written with two letters that doesn't have a symbol, or not an object, excuse me. There's only one thing that you can interpret this as that does not have a symbol over it. The only thing you can interpret it of is the length of a segment. And in this particular case, AB. Okay? So I hope that helps, and come back and watch the next video.